this work? We'll see. Anyway, indexable structures. So now I'm going to remove the Haskell language server. I don't think we're really testing it anymore. And we'll say objects by example, chapter 8, indexable structures. All right, cool. So lens is a batteries included library. This means it includes not only the basic object type, but a lot of useful helpers for common tasks. One of those is working with indexable data structures. What do we mean when we say indexable? Indexable structures store values at named locations, which can be identified by some index. Does a map count as this then? Like data.map? Because the named locations are just the keys, I guess. And then like a vector would have sort of named locations that may or may not exist. Well, same. Oh, it does say this right here. Specific location. Yeah, so using a numeric offsets, lists name their slots using a numeric offset. Maps use a key. Even certain tree structures can label their values. For instance, a rose tree, a tree with lists of children at each node. If you've been watching the stream lately, you'll know that I've been experimenting with data structures. So apparently a rose tree is one I need to experiment with as well. I don't know anything about it, whether it's good or bad or whatever. Okay, anyway, each of these data structures have the same notion of getting or setting the value at a specific index, and there's no unified interface for doing these things in Prelude. Each structure has provided its own separate methods for getting or setting values. This is not only annoying, it also means that we can't easily generalize functions. Sure. Here are some examples of common data structures. And the sorts of index-based operations. Actually, here's what I'll do. Let me put the book over here so you guys have an easier time reading it, and then I'll put the code over here, and we'll just leave htop kind of just at the bottom there. That probably is the best use of space. Okay. So, yeah, we use an int. Hopefully anyone who's seen Haskell, and just for reference, if you're a beginner at lenses or Haskell, like feel free to just ask questions. I'm here to help. Like I want to help people understand Haskell and the code we're writing. One thing I just realized we forgot, so I have to actually close this, is our packages from chapter 7. So we just need a few things. Apparently we need either, I'm not exactly sure why, but I don't even know what that does. We probably use, I'm not sure what we used for that. So let's just add lens for now, and we'll go from there. And then import control lens. We'll see if that adds any memory there. Okay. I think it's control lens. I haven't done this in a while, so hopefully I'm not like completely useless. All right, so 0, 1, 3 is out of bounds, so we get an exception. The prelude by default is not safe, so you get an exception. Lists don't have a built-in way to update values at an index, but we'll sort that out ASAP. We know what a map is, so I think we can get rid of it, or skip it, excuse me. So this is basically as tuples, key value pairs. So we have Leo and Raph. And so these are Ninja Turtles and their corresponding weapons. There's a lot of great references in this book for your knowledge. Oh, and by the way, if you didn't know, that's the book that we're working on, if you want a copy for yourself. I don't get any money for it, so don't worry about it. Oh, and you get $10 off. I forgot about that. Chris was nice enough to give you guys $10 off of the book. Okay. Adjust. I haven't used this in a while, but yeah, so we have a function that basically takes an A to an A. And yeah, so this is just like prepending 2 and a space onto Leo, or onto the key katanas. So Leo has 2 katanas and Raph has a sai. Well, he technically has 2 sais. You'll notice that not only are the interfaces for maps and lists different, lists are missing a way to update values at specific index. The one method they do have for retrieving elements is partial. It might crash our program. Ooh, tough accusations. Accessing and updating values with ixt. Is that how I read that? Ixt? Indexed? Why can't we just call it indexed? Is there something called index already? Is that the issue? Must find out. Indexed. Okay, so this class is like indexable, I guess. Something like that. Or indexed. I'm not sure how to pronounce that. Anyway, we'll say indexed for now. The indexed class contains the ix method. It takes an index from the structure in question and builds a traversal over the value at that index, so we can get it or set it as we please. Ix builds a traversal rather than something like a lens because there may not be a value at the specified location. Okay. Sure. You'll notice the type signature also mentions index M. And X value M. Where are these coming from? Index and X value are both type families, which tell us which index type or value type to use for a given structure. Yeah, so this is like the pattern matching at the type level, I guess. If I remember type families correctly. I think that's right. If you want more information about that, I worked through the Thinking with Types book, but I don't feel like looking that up right at this current moment in time. But I think this means like so we can pattern match these things out later. But that book is also available. Great book. Okay, so type instance index list A is an integer, sure. Type instance index for a map is a k, the key, yep. And the x value is an a and a value. Okay, I understand what this means. So it's just like wrapping the types for the generic functions. I understand. Yep. You'll rarely, if ever, need to write implementations of these yourself, as all the main types you'll regularly use are provided for you already. Nice. If you create your own index structure, you can easily implement these type classes and type families yourself. Sure. Okay, so accessing and setting values with ix. Okay, so essentially what we do here is we just start with the letters of the alphabet and go through the examples. So it's like we'll have Borg, Kardashian, Talaxian. I don't recognize this reference offhand, Is this like Star Trek or something? I see Vulcan down here, so I'm guessing it's Star Trek. But I didn't really watch Star Trek, so sorry. So we can say A. I forget exactly what this one is. Not code action. So getting. Is this just called? Is it just get? No, because that would be just caret dot, right? That's just view. Man, yeah, this is set. Yep. Is this really just view and I'm like being silly? I guess we can just replace this with, or we can just look at view. From lens. Except it can fail. Okay. And what's the regular view? Why am I blanking on what that is? Is there a shorthand for view? No, that's no worries. I appreciate that. Okay, so I was right. So caret dot is regular view. Okay, cool. So with the question mark, it can fail. Okay, so right, that makes sense because since we're doing traversals with indexed structures, they can fail, right? That by definition, that's true. So actually down here, I just want to do stack REPL. Oh, okay. So we want, I guess, the library. Can we pick this? I mean, we just want one, I guess. Wait, what? What is it building right now? I don't understand. Didn't I do stack build up here? Oh, it's probably building lens with GHC 884, right? Because we updated to 884 and then imported lens. So we need to build lens with 884. Hey, I forget. Okay, so how do I pronounce your name? Is it just, should I just call you Vlad? I don't know what the C stands for, actually. Just Vlad will do. Vlad is fine. Hey, how's it going? I watched a lot of your stream, but I had to step away for a while. C is for the last name. That's good. Vlad is easy. I can do that. So I don't know when you popped in, but we switched to Haskell language server over Haskell IDE engine. And right now we're working on indexed structures with lens. And unfortunately, we have to compile lens with GHC 884. So that's going to take a little while, but this computer is a little pretty fast. Yeah, it's pretty nice. It was really easy to set up. Just a stack build, and everything seems to work just fine. So actually, let's stack build J8, I guess. I think that's half my cores. I think 6 is technically half, but that's fine. So it seems to be working thus far. I've already noticed there's a few features that are here that weren't available in Haskell IDE engine. So like the if I just okay, let me show you an example. So before, if I looked at the diagnostics for a symbol, it wouldn't show like the anything under here. It would just show this. And so it shows now the generic signature and the specialized signature, which is really nice actually. And when I did this on putsterlen, like if we just do c equals putsterlen hello or whatever, and we do this, oh well, it's different now, which is interesting. I'm not sure why it's smaller. Oh, okay, so it decides how much space there is and makes a decision. So it'll tell you where the documentation is on your computer and where the source is, although it won't take you there. And then this one doesn't have any more information, but I was hoping it would show that on the machine, but maybe it's not there yet. So anyway, I think it's pretty nice thus far. It's small improvements, and as long as it doesn't blow up my computer, I'll be happy. So we're gonna try and run it. I'm gonna try and not close it from now until the end of stream, and we'll see if we have any memory leak issues, but I don't think that we're gonna get. Okay. So the only things I can get it to do reliably are type on hover and fast in-editor errors. Yeah, it's been, I think even the Haskell IDE engine has come a long way since I first used it. Like when I started streaming this stuff, what, a year and a half ago, we tried Haskell IDE engine and it would crash pretty reliably. It would take down the stream, in fact. And so I switched, and then that tool started breaking stream. So I switched back, and I haven't switched from Haskell IDE engine for a while, and this is the first time we're trying something new, and it seems to be okay so far. But we'll see if we have any memory issues later. Hey, Iodine, what's going on? Yeah, I can't get go to definition right now. So like if I hover here and do GD, I just get definition not found. So I don't know. Now if I write, I think if I do it here, GD, it will hop. So I can get go to definition for stuff local to this. Yeah, you said it there. Works well for in-package definitions. Okay, great. So it's the same as GHC IDE then. Yeah. I mean, not surprising. They're the same thing, right? They're both GHC IDE behind the scenes. They're just a different name. So you still get go to definition, but not for standard library stuff. Or well, Lens is not standard library, but you know what I mean. All right, let's keep going because I think that I understand what this is doing. We need this. Will it compile if I just put dot there? Well, I might not know because I'm building. We'll see. Let's try both. Oh. All right, so we got view and we got view can fail. So we'll see if both of these compile. It looks like it is because the GHC IDE is responsive, but like how? It hasn't even compiled everything from Lens yet. That's interesting, actually. I'm kind of surprised it's working, to be honest with you. Okay, so this should give us just, and this should fail in Siri. This should produce an error, and then this should extend, should produce nothing. Okay, that makes sense. We'll try these out in a second, I promise. I just need to compile this first. Luckily, we only have to compile it once, so. Lens is kind of a, well, actually, I have to compile Cabal, which is the problem. If I didn't have to compile Cabal, it wouldn't be a big deal. All right, so then we have D equals A x1 set Vulkan All right. So yeah, this seems pretty normal from what we've seen before. Oh yeah. This book is fantastic. Is was it called Lens by Example at the beginning? Yeah, honestly, I think the book is fantastic. I actually really enjoy it. I feel like I've learned a lot, so that's nice. Some of the type shenanigans that happens here is a little over my head. Um, like looking at the types, sometimes I don't really understand them, but um, you know, like yeah, all this stab stuff. This one's not too bad, I suppose. Yeah, the names are tough too, right? I mean, and also like the types are a little tough, and the naming is tough because you have all these symbols all over the place. Um, it's in the stream title. I didn't know that. Um, I don't like reading on stream necessarily, but mm. Okay. So if we try and set something beyond, I promise we'll test this stuff out here in a second. So it's coming. Romulan. Oh yeah, it's definitely Star Trek. Yeah, a lens is a subset of a larger field of optics, right? Whoa, 12 viewers. Hey everybody, how's it going? We're compiling and learning about indexable structures. Okay, so in theory, this should produce a runtime error if we try and run it. This one should produce nothing. This will return just Cardassian. This will set this first element to Vulcan. This will return the original list because there's nothing to index at position 10. So that's pretty interesting. Okay. Very cool. So traversals handle missing elements by simply not focusing anything. So if the value at an index doesn't exist, then view will return nothing. Surprisingly, we can't set missing element. Is that surprising? Oh, surprisingly, we can't set missing elements to insert them into a list or map using X. In order to be consistent with the traversal laws, the X traversal can't add or remove focuses. Okay, that's that makes sense, I think. Um, yeah, I mean, if you're obeying laws, it's one thing, but I suppose you could try and put something at position 10 in an empty list, but like, what would you do with the rest of the locations? I suppose it wouldn't make logical sense. Like a map might make more sense. Like if you tried to index a key that didn't exist, maybe it could add it. But what would you do in the case of a list? So I think that makes sense. Okay. So let's see if this works. We'll have to see. So this is one feature that I remember being really useful, and we'll see if it works. Toph, Earth. So this is from Avatar. What's it called? Avatar: The Last Airbender or something? I'm not a big. All right, let's see. No module name map. Can you import it for me? What? Why are you suggesting those? Oh, because I don't have containers. Okay, so if we do package containers No. And then we do restart COCN Vim. And then we'll try and see what happens. Save this. Okay. What does it try and do this time? Nice. Okay, so it doesn't understand how to make suggestions outside of what you have imported, which I suppose makes sense. Like, how would it possibly know to do this? Now, one thing I did notice while thinking about this is that I can just do M, and it's going to try and make a decision of what to do, which is actually nice. So like it knows that if I say m.fromList that I want import that. So actually that's fantastic. It would be cool if it could do both at the same time. Like it could say, oh, you know, when you say data.map or map.fromList or m.fromList, you probably mean you want containers and you want this. So that would be nice, but this is still pretty good. I'll give it that. It's better than it was, I think, because before I don't think it would do that correctly. Yeah. I mean, again, we're still in sort of infancy with this whole GHC IDE stuff. A lot of other languages have much better support right now. I mean, for me, it's been really good. I mean, just being able to know that the compiler is it's not compiling has been pretty useful for me. Okay. Anyway, I don't want to complain. I'm very happy with what I have. Could it be better? Yes. Could it be worse? Yes. Agreed. Oh, that's a good question. I haven't tried GHCID by itself. I could try it if you wanted to. I could see if it works for me, because I know that actually, I think that may have worked in Haskell IDE engine. I'm not even sure. The thing about having containers in package.yaml is important, because I didn't have that before. So it's definitely tricky. So f x soka. There you go. Yeah, thanks, Penzance. It's helpful. HS import. That's the key. That's what we need. And I actually am trying to remember what I set for the default. Wait, why is this? Why is this installing? Oh wait, right, we're just building. Why should it build Ormalu though? Is this one of the ones where the build is per project, which I think is separate? So like in Haskell IDE engine, this stuff is separate from your development environment, but in Haskell language server, they're together, probably. So you need to install GHC IDE into every directory that contains a Haskell project, I guess. I wonder how they got around that with Haskell IDE engine, because you don't have to do that with Haskell IDE engine. Or maybe you do, and I didn't notice it after I compiled it the first time. I don't know. These are kind of things I don't really think about very much. Okay. Anyway, I don't think we need to write any more of these. I get it. Um, if you try and set a value that exists, it will change it. If you try and set a value that doesn't exist, it won't do anything. Okay, cool. So many data structures have reasonable indexed instances provided for you already. Here's an incomplete list and their respective index types. So sure, list, non-empty A, just essentially a list. What's a seek A? I'm not actually sure what that is. Is seek A just a ascending list or something? A strictly ascending list? I'm just guessing. Vector, sure, set, map, identity. That's kind of interesting. That's I guess it's indexable, sure. Kind of interesting. Text, okay. Byte string, okay. Function. Its index is E. Huh, sure. Well, this is not any function. It's a specific function. Okay, we're done. Nice. So stack REPL, enter, I think. This is different. Okay, let's pick one. I'm confused. The main module to load is ambiguous. Oh. You see what I did here? Anybody see it? I built from inside here. That was stupid. If I do stack build, it's here, and it's probably fine. That's funny. Okay, anyway. Oh well. So actually, let's switch these back because I'm going to use the REPL. That's funny. It's no wonder it took so long, and also why it was building the things I was not expecting. So anyway, I suppose I deserve it for being confused. All right, so B. Let's save this and reload real quick. So B should return. I'm not sure how to pronounce this correctly. I know it's not supposed to be Kardashian. It's probably Kardashian. Yeah. Well, it wrapped in a just, right? Because it can fail. B prime. Oh, B prime works because we've indexed correctly. Let's change it to C prime because I guess. And then we'll run C, which should return nothing, and C prime. Oh, interesting. I was expecting like a runtime failure or something, but that's not what happens. It must just provide a default to view, like it doesn't exist, so here's a default value. That's kind of interesting. Oh, that unexpected. So not D. D should replace, yep. And then E should do nothing, yep. And then G should give us fire, just fire, and that should give us nothing. G, just fire, H, nothing. Great. Okay, not surprising at all. Indexing works with monomorphic types like text and byte string, just as you'd expect. I think we understand the setter, so let's just ignore that. H. All right, so here's another situation where this won't work, but we can make it work. Oops, it's the wrong way. So yeah, see, it's like it just doesn't fully understand yet. So f package t text restart save. Takes a few seconds to boot back up, and then there we go. So 5. Oh, right. So this is going to need. Oh, interesting. It doesn't try to do that, which is weird. But we can just do. I was expecting that to work. T.pack. It's kind of weird, actually. Shouldn't that work? Do we just need? I think we just need overloaded strings. But like, why doesn't it suggest that to me? Language overloaded. Oh no. Oh no. We lose this. That's so sad. So in Haskell IDE engine, oh, there it goes. It was just being slow. Whew. I was very concerned for a moment there. I would have been very sad. So this should work, and then this should be fine now. Okay, cool. Apparently it was not. I don't turn anything on by default, but you know, that's probably one I should just turn on by default. Although I guess occasionally you do get situations where it's annoying that it's turned on, but it'll be fine. Byte string, potentially index 10. Well, does it know what this is? No. Where's byte string from? Is it just byte string? There's a fly in front of me. It's driving me insane. Yeah, okay. 6. So there's a little bit of, you know, back and forth between package YAML and lib here. You know, if you had a sort of mostly finished project, I guess it wouldn't be so frustrating to have to, like, most of this would be done for you. But I kind of like to, I just start from scratch for each chapter typically, so I have to build these things up. And I mean, I guess I don't have to, I just do. I should probably like create a stack template and stop doing that, but it's fine. There are worse things in the world. Right, so we need to reload the REPL. I suppose I could have included byte string and text. Yeah, but I don't know. What's faster? Control D, up enter, or set -x byte string? Is it X? It's not even X, it's package. Anyway, I suppose I could have copied and pasted them with my mouse, but that's awkward as well. So anyway, so I should return just H, and then I guess if I do 0 here instead, this should return just something. 104, sure. I don't know byte character codes for lowercase h offhand. Anyone that does, I would be impressed. So if we want to, we could say ampersand, the first one, set with plus. So this will basically partially apply the plus function with 2 and then apply it to whatever's at the index. Whoops. G, this is K. I swear I know the alphabet. I don't. I constantly do this wrong. Oh, sure. Yeah, I guess this does move things to the right because the byte representation or the integer representation of H IJ is just whatever it was, 104, 105, and 106. That makes sense. I don't think about this stuff very often as like letters in byte string or whatever. All right, so this is pretty wild. So we're gonna say, give me a text object, focus on the E, and this is toList of, and then I think that's right. I gotta look this one up again, but I think this means toList of, and then it's like given any input, just create the IOU. Do I really need that? It seems to me like it should be able to figure that out. Oh, it can't. I mean, that's probably why he wrote it there, but okay, so it has trouble figuring out the type apparently, because it's probably like, well, let's look at what the error actually says. Oh, okay, so it doesn't understand that it's applicative. That's fine. Which is interesting, but sure. So if we say it's a list of character, it uses the list applicative, and then we're good to go. I guess text doesn't have an applicative instance. Info text, import data text st info t.text. Nope. Yeah, I guess that makes sense. And it would probably by default try and turn that into a text. Yeah, exactly. Yeah. I was just double checking. But it makes sense that it wouldn't be applicative. Although, like, well, it's the wrong kind. That's the issue. Yeah. Like, you could define a functor instance by pretending it's a list, but you can't in Haskell because it's got the wrong kind. You would have to write a new type. You would have to write a wrapper around text to make that work, I guess. Okay, does this actually do this thing? Because that's pretty weird, I would say. It does. And I think that that is what this does. It certainly doesn't look like it, but it's very weird. So like a lot of the examples in the book are quite strange. This one seems a little less practical than some of the other ones, but like in the first chapter, he shows you like, or maybe it's the second chapter, I don't remember exactly. But he shows some of the weirdest examples I've ever seen. Like, why would you even need to do that thing? So like, let me give you an example of like a lens that he wrote. Let's just do ZYX. You know, right, so you can write a lens that turns this into like that. Like you can sort the characters inside these crazy nested tuples, for example. They could be triples or quadruples, but you can write like absolutely wild lenses that do things like this. I don't remember exactly what he showed, but I think they're in chapter 1 or 2. They're really wild sometimes. Okay, so let's round out our exploration with a quick look at a few structures whose index types may not be entirely clear. Consider the following tree. We encode this as a rows tree using data.tree. Is data.tree just part of containers? I really don't know. Let's find out. So m tree int node 1, node 2, node 4, node 3, node 5, whoop. I had my caps locks on. Pretty useful. It would be nice if it didn't have to take two, well, that's like actually 6 button clicks to do both of them. But again, we can't, beggars can't be choosers, as I guess. What's the issue here? What is this complaining about? It probably means that tree is not here. Oh, maybe this is supposed to be sure. I mean, doesn't matter. Just be an integer. I don't care. There's not supposed to be a comma there. There we go. Cool. Yeah. So let's see here. Does this still break? It seems like it shouldn't. Will it fix this for me? Oh, hell yeah. That's awesome. That was really cool. I wasn't actually expecting that to work. I don't know if it worked before, but anyway, that's actually really sweet. So yeah, I'm thumbs up with Haskell language server, by the way. Yeah, I guess that's true. Like it probably shouldn't have done that in the first place, but it's slowly being fixed, and you know, I think now that the efforts are put into one place, that's really helpful. So we'll see how things work in the future. Also, hey Lumi, how's it going? All right, so this is a rows tree. Interesting. If you look at the chart, you'll see that the index for a tree is a list of integers. Starting at the root of the tree, we pick the child node which corresponds to the first integer in the list. Then descend into that child and treat it as the root. So does anyone know offhand the sort of implications for like when is a rose tree better than another tree? Because I just don't. Excuse me. So 0, 0 descends into the first child twice, then focuses the value at that node. So these can only ever be 0 or 1, basically. It can only ever be a list of 0 and 1s, because it's like go left, right? Go left, go left. This is go right, go left. Go right, go left. Okay, that makes sense. That's cool. Let's put 1 in here. M try to view x 0, 0. And then up here, let's put a little note that says like another name for rose tree is multi-way tree. Maybe that helps illustrate its differences. Oh, okay, I see what you're saying. Yeah, like kind of how it's constructed, I guess. I don't know. But it feels like some sort of binary tree again. Well, I guess it doesn't have to be this way, right? Oh no, because you always have to have a node. Oh, okay, I see. So this could actually this could have 3 things, right? Is that a valid tree? Like if I did node 7 here, this is a valid tree, right? This is just for my own understanding. So it's not just 0s and 1s. I'm going to guess that that's probably reasonable. So this is like sort of left. So this means index of first subtree, index of second subtree. So if I do 1 and 2 in this case, n should be 7. Nice. Okay, yeah, I understand. We can also update existing elements using ix, just as we can with list and map. Great. Maybe you saw on the bottom of the chart that we can actually use ix to index into functions. This one's more of a fun trick than something you should use in production code base, but maybe you can show it off at your next dinner party. You guys want to have a dinner party with me so I can show you this? Or who's going to a dinner party anytime soon so they can talk to their friends about the ixt type class. That's a funny name. You'll see the name here in a second. Hey Janpoon, how's it going? Yeah, anyway, so a function has an indexed class instance, which is kind of cool, I guess. The index to a function e is its argument e, so it's kind of like it's a reader, more or less. It's like an indexable reader. I don't know if that's the right way to say it, but something like that. We can actually access the value stored at a specific E. Oh, right, because it's basically like a map for a continuous key or something, right? Like if you had an integer to whatever, you could basically store an infinite map from E to A. Yeah, there it is. Yeah, I appreciate the follow. So that's kind of cool. We can access the value stored at E. I already said that. Okay, yeah, I see why they're saying it's a funny like party trick. Reverse is a function which you index like it just runs the function, and so like does it define for any input? Yeah, it's kind of strange, but yeah, it's interesting. I like this one. So if we try to reverse a function and then use a setter, oh, I did it backwards. I would imagine this is going to complain because actually maybe we don't need this. Well, we're going to need it in both places, I think. Let's just do the following. This should return just string. Just. I'm such a doofus. Shouldn't it? Oh no, this is a setter. What did I do wrong here? I see it. Reverse at x password dot tilde, you found a secret. Okay. Which one of these needs to be string? Maybe it helps if I change it to list car. No, doesn't care. Okay, so let's change this. String. And see what magic fixes it. Okay. Apparently we only have to make one of them a string and then it's fine. Let's see what the result is. Oh, you know what? Maybe the result is being turned into something else. Yeah, see you, Penzance. Thanks for hanging out. Appreciate it. I just realized what this is doing. If you give it the thing it can index, it sets it. That's cool. Man, that's really neat. I assume that's what you guys were saying when you were saying it's cool. I like that. Yeah, so p password. Oh, reload. You found the secret. You guessed the magic word. Okay, so that's a cool function. So now we're going to talk about inserting elements, and I presume you can only insert one at a time, and you can only insert in certain places. Okay, so I guess the difference here is that one is a lens and one's a traversal, and it's a maybe. All right, so it's got to be like, so if you have or if you try and insert at n+2, where like n is the length of the list. If you try and insert at n+2, it's not going to work. But if you insert at n+1, it should work. And I presume you can also insert at any location in the current list, maybe. So let's experiment a little bit before we even look at the answer. So Q, we'll start with a list 1, 2, 3. We will x 0, 1, 2, 3, and we'll try and we'll at 3 set 4. Expected. Maybe you don't do set. That's the result type. How do I guess we scroll down. Oh, just for. I also have this backwards. Okay, so now this needs to be Q Why does it need to be a list of integer? That seems weird. I don't understand. Yeah, I know that this is a map, but I'm just curious how I do this with. Oh, interesting. All right. That's interesting. I wasn't expecting this, basically. Right, like these to be justs. Sans. Delete elements. Okay. Oh, okay. So we can't do this with lists. Okay, that's fine. Yeah, I guess that's enough information here, right? Yeah, okay. I was hoping that you could. That'd be kind of interesting. but I guess there's no way to like do the bounds checking, but also it seems like there is, but I guess it's a lens and not a traversal. I don't know. I don't know enough about this to like have a good answer. Ah, I see. Okay. Map-like container. Interesting. So I think I already have this as F. So we could say F view at Zuko. I think it's F. Yeah. Excuse me. So P. What? Oh, it's Q. I had P. They look the same. All right, so we can actually delete values by setting them to nothing. So we could say RF view at Zuko set to nothing. But it's got to be this. Okay, and that will drop that, and then there's a helper function called sans for this. So cool. Very neat. We could also say s at hello just world. Haskell would be so cool if there's only one type of string. It would be helpful. That's true. Like if string was just text, I guess at this point, probably. But should it be strict or lazy? I don't actually know. Probably strict by default, I guess. I think the same thing could be said about list, right? Like list should probably be vector by default at this point. I don't know. I would be curious to hear what you guys think about that too. Sort of why it's nice to like, yeah, it's like the performance characteristics of all of these things depend on your application. So, and then the other thing is like backwards compatibility and stuff. So things become pretty complicated very quickly if you try and just replace those things. All right, so this should add a key hello with the value world, I guess. So nice. Not terribly hard. I don't know if that's actually true, but you could be right. I mean, I truthfully don't know the answer to that. I mean, there are alternatives to Haskell that you could just use that are strict, right? Mm-hmm. I don't know. I think it's complicated. Okay, so there's a fly in here. It's driving me crazy. Here, hang on. I'm gonna mute and try. I think I missed, unfortunately. Yeah, you can always turn that strict values plugin on which kind of tries to make as much strict as possible or be specific about where you want to add it. All right, so apparently there's also S prime. Well, let's just copy this. Where this is just question mark set. Oh man, all these little symbols are tough. Mm-hmm. We can use this with other optics if we want, but it's usually used with at. Okay, yeah, because this is like, this is totally fine to write, but you're just going to get just in front of it. I see the point of this. Yeah, the strict. Okay, so we got sans, which makes it easier to remove stuff. We have sets. So prime data set 11. Okay. Okay. So because I was like, wait, why would this work? But it's just saying that, is it a member of the list, yes or no? A member of the set, sorry. So is this a member of the set? Yes. And then if we want to add a value to the set, we could say v equals primes at 15 is not prime. I actually don't know what the next prime number is offhand. 19? No. I don't know what it is. Whatever. We'll just say 14. Question mark tilde just. Oh. Like that. Splitting a string into graphemes wrong. I don't even know what a grapheme is, but I will assume that you are right. V. All right, so we can add 14 to the list that way, or to the set. I keep saying list. I'm sorry. Sure. Yeah. No, that makes sense. Like being able to deal with that Unicode correctly is obviously useful. Okay, so Oh, okay, so we're gonna build one ourselves. So exercises, indexable structures. Fill in the blanks. Sure. W, Larry, Curly, Mo, the lovely Three Stooges, underscore 1 set Wiggly. And this should return, oh, I thought I got rid of that. Larry, Wiggly. I don't remember Wiggly. I assume that's also a stooge. Oh, how does this look in here? I think that's the same. So we can just use X here. We have to use X, actually. We can't use at, right? Because at wouldn't work. X. Superman, Lex Luthor, Batman, Joker. Sure. These should probably be like this, I think. This is how let works here, right? HV and underscore Spider-Man, Spider-Man, just Goblin. This has to be at and this should return Goblin. I don't think I even really need to test these beforehand, but it's fine. Y. Ah, of course. So this is Sans. Sorry, I'm getting tired. That's Sans. And then this is going to be question mark tilde. So I think we want to add y and delete I, apparently. I'm not exactly sure why we're deleting I, but we can just say nothing. I think this should be asked from list AE OUY. Okay, so let's test them. W, Larry Wiggly Mo, nice. X, Batman, Spider-Man, Superman. I suppose Spider-Man will always be in the middle, but I don't really know. I don't know if that order is guaranteed, so on different machines. I will assume yes, but what do I know? Y, nice. Z, nice. Any questions thus far? Everybody doing good? Use X and at to go from input to output. Okay. So input and from list candy bars 13. Soda 34. I don't know what this means. 1334 seems like a weird number. Like the scale is all off. I mean, I suppose there's no units, so. Okay, so we need candy bars. Shorter. Okay, so A prime is going to be input ampersand. Excuse me, we want to delete gum. We want to add ice cream. Why do I keep writing scream? So what's wrong with me? And we want to modify soda. 2. We probably can't do that. That's fine, we can just set it. 37. Yeah. I wonder if there's a way to do over. Is over Oh, it's 3. Cool. So that's neat. I wanted to see if we could use over, and we can, but we gotta be able to map onto a maybe. So as long as we can map onto a maybe, then we're good to go. So we just use fmap there with the section plus 3, and that's actually a section. I'm trying to work on my calling things sections correctly. I called way too many things sections before. So that's kind of cool. I wonder if there's a helper for this one. I don't know what it would be. Like maybe I think it would be awkward because you'd have to do more interesting stuff. Anyway, okay, sure, cool. About 2 hours. Supposed to stream for a whole nother hour. I'm exhausted. Okay, keep going. Custom index data structures. Nice. We can implement the indexing type class ourselves if we want to use ix or at for one of our own types. Let's see how to implement these by writing a new list type, which implements an alternative version of indexing. Cool. So let's build a new type over lists, which handles indexing as though the list were infinitely cycled. Sure. So new type cycled. I'm guessing that's it. When we look for index 3, we reach the end of the list. If we cycle by continuing to count, then we end at A. Sure. 1, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negatives, sure. We expect setting to work as well. X0. Oh, sure. Yeah. Because these are characters. I didn't fully understand this at first, but it's just characters. Yep. So 10, yep. And -1, sure. Okay. Error invoking format overlapping edit. The heck does that mean? Overlapping edit. I have no idea what that means. I don't know. Okay. So int traversal cycled a. These always throw me off when I see something like this. I see I handler, but I only see one arrow. It drives me a little bonkers, but no, it's fine. All right, so cycled fmap traverse of. Yeah, it's like, it's so weird to see, and it's very confusing as a beginner. I mean, I guess I'm not really a beginner, but like, I'm missing. So we need some extensions, and then this works, but I don't know what this means. Okay. It's very hard for me to remember this, but this looks familiar, like now that I'm writing it, but like, you know. All right, so we have a handler, an integer, and then our list, basically. So we say I'm guessing x here is the list x. Yeah, that makes sense. Yeah, this makes sense. I guess, but not really, because okay, so no, and I think the reason is just that, like, if I saw this function immediately, and I then saw, like, if I saw x, you know, int to some other thing, one, like, specifically one thing, like result. I'm just gonna write result, and then I saw x I equals. I would be pretty confused immediately, right? Because why would this return a lambda? Because this doesn't look like a function to me. If it said, on the other hand, you know, something like this, then I'd be like, oh yeah, sure, of course, no problem. But I think that this is probably better to read for me. If that makes sense. Yeah. It's not the worst thing in the world. It's just, it's hard for me to read. I don't fully remember the semantics of traverse of, but like I think I see what's going on here with this, right? It's just like, just take the index with the modulus of the length, and then you're good to go, right? Because it doesn't, it's no longer cycling, or it doesn't seem to be cycling. But you can do this with negative numbers. I guess I never really thought about it. This is the remainder after division. Like, is the modulus of a negative number defined as being positive, or is it always positive? It's the remainder after division. What's okay. So if I do rem3, got it. Thank you. That's actually useful. Or does this just always return -1? No, that's okay. So the modulus just takes the absolute value of the subtraction, basically, between the two things. Something like this. I've never done a modulus with a negative number. That's why I'm confused. Nor, I don't use the remainder function in Haskell very often either. Is this the same in Python? I'm like now interested. Yeah. I don't know what remainder is in Python, so modulus is defined correctly. There's probably from math import remainder. Okay, that's fine. It's interesting that it returns a float. I don't know why it would return a float, but whatever. Okay. I can look at that later. That's interesting. I don't want to think about that right now. But I didn't actually realize there was a remainder function in Python, so learned something new about that as well. I have seen rem before. All right, so this sort of makes sense. I'd have to go back and look at my notes on traverse of, because I don't actually remember what it's doing. By so it's like I can't remember what traverse does exactly. Traverse of does exactly. I mean, it clearly just traverses a list, but what is this handler for? The handler, I guess, is what it looks like, a pure function, but I guess it doesn't have to be. It just needs to be like an A to A function. That's how it deals with setting, right? It has to be an f of A function that's an applicative to do set, I think. Oof. It doesn't do anything really. The handler? Just takes a traversal, you pass it, and returns it back to you. Oh yeah, okay. No, I understand that. I understand what traverse of does, sort of. Like I really do need to look at a few examples, but um, for the list, I know that traverse of basically just focuses on every value in a list. It's really the behavior of handler that's throwing me off a little bit, I think. Because I guess we could do traverse of not any, not all, it's each. No, I don't remember exactly how this works. I'm just guessing. Anyway, let's see how it behaves. We can just do this one. So B prime I think is okay. I think I used C prime earlier. So we'll use B prime. Cycled. C. X. -1. Set. Yeah, I mean, it works. All right, so in this section, I'll show you how we can actually index any arbitrary type. It doesn't have to be a traditional container type. So as long as we can implement the type class, it'll all work. Consider a data type which represents an address. Addresses are complicated, blah, 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 blah. I don't want to write this much. I suppose I could have shortened the other ones, but whatever. Yeah, so this is a classic one where the code actions don't work, but the solution is simply add template Haskell. Uh, so now we need to have some sort of pattern match go here. So that's what this is for. I see why this is down here. That's fine. Ugh. I hate this down here. I'll just write it out. Okay, so now we must think of implementing at. Indexed is a superclass of at. Everything that implement at must implement indexed, so we need an implementation of that as well. But luckily for us, there's a default implementation of indexed in terms of at. If we define at, we get indexed for free. For free. Lens prime addressed AB string. What's really funny is from writing so much unison lately, I want to use lambda case instinctively for this, even though I don't have to. That's kind of funny to me. Okay. C prime we already used, so we can go straight to D prime. So at street name This is kind of interesting. It seems it's pretty interesting. insensitive. Okay, you can specialize to string or text keys, write the X instance manually, even though it has a default implementation. It's okay to assume that user will only interact with the map via ixt and at. Okay, so basically we can use lower is what they're saying. We don't have to worry about them. We can just insert everything lower, and that way we're fine. If they're only ever using ixt and at, then we can assume their insertions are happening with ixt or at. Okay. So new type CI map. I guess like this. I think. So, okay. And then we're gonna say type instance x index. Index CI map equals string. Type instance x value CI map equals a. Instance x CI map a where ixt. Let's copy this. Actually, let's just copy this whole thing. Ixt. Okay, so this is our key, which will be a string. Okay, this will be AA, this will be CI map A, this will be CI map A. CI map, and then this will be an actual map. Then this will need to be a CI map, I believe. And then X will now take no. This is map, and then this will be map, and this will be to lower fmap I. This comes from data car 7. I think that's right. We can write a quick test. df prime. So we'll say ci map m dot empty string. Wait, what are we trying to do? String or text keys? Yeah. So at hello world. So this is gonna be string. This can also be string. Oh. X. Deriving show. Okay. So let's change this to m dot from list hello derp. Doesn't matter what it is, actually. Wait, why does it have to be in maybe string? What? I think I'm trying to do the wrong stuff. I think this is really what I'm trying to like accomplish here, is like that if we do this, we get 0. If we do this, we get nothing. Perfect. Okay, so that's what we expect, I think. Nice. Then we want instance at ci map a where, and then let's go get this. This is now going to be a. This is going to be string. So we need to do what? We need to view with 2 lower? It's like we need to build a lens. So is it just Nah. Let's do the other way. So this okay, so we should probably rewrite it to handler. So this is like, wait, why does it take a string first? Is that right? It takes an address, the index, which is the string, and the value, which is an A. So it just returns maybe A. Okay. So this should be like string to okay. So that's the right type. So we have a string, we have a handler, and then we have a CI map. So the map itself already has an at instance. So we should be able to just write CI map fmap at to lower fmap key handler map. This is usually written like no. Wait, what? Oh, doesn't this need to say applicative f? And then we can write CI map. Okay. I don't fully understand why it's complaining about applicative here. Like, why could I not? Okay, whatever. Um, is this right? I have no idea. Um, so we should be able to say at, well, ampersand, at hello set world. Then we should be able to say yep. So that seems to work. That's kind of interesting. So for this implementation, I kind of just followed the type checker. I don't fully understand why I can't write applicative here, but it must be just the definition of at, I guess. It must require functor and not applicative for whatever reason. I suppose we could just import control lens info at. Interestingly, it doesn't require functor. So does lens prime? Info lens prime. So who requires this functor? What if we remove the type signature? Examples. I don't know what. That's kind of cool. So some of them showed like a specialized version of what this F map is, but this one doesn't. So what if we just look at this parenthesis here? So it must just be that lens is a functor. But if I remove this F, it's unhappy. Index. Oh my gosh. Index CI map A. It must be in this index thing, I guess. Because I don't see where we're getting functor from. Not obvious to me. But apparently we can write functor. So that's index, which is interesting. What does it say actually? This is index CI map A. It's very interesting that I can F map two lower under on it in the first place. The types are very weird here. What's the type of handler here? Maybe A to F, maybe A, as kind of. And then this has to be just CI map, I guess. Okay, the type is strange here, but it appears to work because I can use at. All right, well, that's like 2:45, and I think we finished this. Let's see if these are the answers. We could have called it case insensitive. I just said CI map. The types are weird, right? Like, again, it's the normal, like, the types are weird. Like, this compiles. If I put functor F here, right? This seemingly perfectly fine. But like if you look at the type over here of key, oh, well, it works there too. Anyway, if we comment this out and then we go save this and look at the type of key, it's an index. Oh, I guess that's just a string anyway, so it's not a big deal. But I'm not fully aware of where functor is coming from. It must be the map functor. This one. Nah, this one can't come from list, right? I think this comes from... No, it can't come from map. How would it come from list? I don't think it comes from list. But I don't know what it comes from. Yeah, I mean the first one. The second one I understand. I'm okay with the second one. It's this first one, like I don't understand where this functor comes from. And unfortunately it doesn't show me the specialized version of this functor. I don't know which one it is. It should be like maybe A, right? So X value CI map A is just A. So maybe A to F of maybe A. but it doesn't tell me what this f is. So I don't actually know. It specializes everything but the f. I think it's just universally quantified in that f. I don't understand universally quantified here. But, okay, so let's say that's true. Why can't I write this? Oh, well, applicative would be too strong, I guess, is the idea here. It's universally quantified in the definition of lens. Okay, that's helpful. Ah, I was missing one piece of indirection. I see. Okay, so I looked at lens prime and I just saw that it was a type synonym for lens, but I didn't go one step further and look at the type of lens. Okay, this makes more sense. That makes sense. Okay, thank you guys. That's really, seriously, that's awesome. Okay, so this functor is the lens functor. Good catch. Must say I do. Good catch. Okay, well, either way it works. It's just the types are a little funky, or were a little funky. I guess they're less funky now because I just need to look. Yeah, like just tell me what this f is. Not the f. Like tell me where it comes from. Yeah. We can't write applicative because it won't type check because it's a lens. The only guarantee you have on a lens is that it's a functor. Yeah, that would be helpful. But I know that the types are quite funky inside lens to begin with, so you have to be clever. Okay. So in these ones, they're going to be a little bit different. They're going to be a little different than the ones I have, but probably not much different. Yeah, this is exactly the same. It's just partially applied. So I could write fmap cimap dot. Apparently I don't need this traverse of, which is weird. I don't know. So we can write fmap dot, or fmap cimap dot x to lower k and get rid of handler and map. Yeah, it's like, it seems weird. Oh, because of the uncase sensitive. Right. So because we don't have a regular new type, we can't do this. Oh, also this is a traversal. I don't think I have this as a traversal. Oh, I do, because it's applicative F. Okay. Well, this looks more natural. No, it doesn't. Doesn't at all. I don't know. The types are weird.